I'll turn this M10 bit on. Right-click and select Modify. Today, we're going to learn how to control a servo or stepper motor using an S7-1200 PLC in a relative coordinate system. First, please create a project. I've already created one here to save you some time. Okay, so after you've created a project, we will take the following steps. First, you will go to the Technology Objects section and select the Add New Object option. After you select the Add New Object option, a window will appear. Here, you select the Motion Control option. Continue by selecting the T option. And U. After you select the T option, it will display a servo axis for you, which is named Axis 1 here. You can change this name, but I'll leave it as the default since I only have one servo motor. Okay, then you'll select the automatic option and press the OK button to finish. And after you press the OK button, a window will appear for us to configure the pulser hardware. Okay, here you will select each section one by one to complete it. First is the General section. Here, you will select the pulse output pin. In the Pulse Generator section, you'll select the Pulse 1 option. After you select Pulse 1, the Pulse Output and Direction Output sections will automatically display the PLC addresses here. Pulse Output will show Q00 and the Direction Output section will show Q01. Okay, continuing in the Unit of Measurement and Position Unit sections. Please select Pulse for me. I'll be controlling based on pulses, so that's why I'm selecting Pulse. Then, press the Yes button. Okay. Next, there are some important parameters you'll need to select the Extended Parameters section. In the Extended Parameters section, we will change the Mechanics parameter. Here, in my hardware configuration, I have it set so that 800 pulses equal 1 revolution. 1 revolution of the stepper or servo motor is 800 pulses. That's why I'll enter the parameter 800 here. 800. There you go. I'll enter the parameter that corresponds to the hardware I've configured. Additionally, there are some other parameters you can configure, such as the limit switch or hardware limit switch. However, since I don't currently have a limit switch sensor connected, I won't select these options. Similarly, for the homing section, I'll leave it as the default. Once you've finished the setup, I'll close this. Okay. With that, we have finished the setup. Now I'm going to check it. First, I'll double check the PLC's IP address. I have it set to 192.168.0.90, which corresponds to the IP address of the actual PLC. So, that's okay. We will switch to the main OB1 section to get into the program. And now, let's write the PLC program. To control the stepper or servo motor, we'll go to the Technology section. Please open the Motion Control folder for me. In this Motion Control section, there are many commands for controlling stepper and servo motors. The first step to control the servo motor is to supply power to it. I'll select the block named Me Power, and you'll drag and drop it into the programming area. Then, press OK. So, the program will create a block for us named Me Power that will supply power. In this block, for the axis parameter, you will select Axis 1, which is the stepper or servo motor that we've just set up. Next, at the Enable input, I'll add a normally open contact so I can control turning the power on or off for the stepper or servo motor. I will enter M10. Okay. So, when M10 is turned on, it will supply power to the stepper or servo motor. And next today, we're going to learn about controlling a stepper or servo motor in a relative coordinate system. For a relative coordinate system, we have the Move Relative command. You will press OK. OK. Next, similarly, we will fill in the axis parameter. We will select Axis 1. For the Execute parameter, I will enter the bit M11. Okay, for the distance parameter, this is the distance it will travel. I'll enter 800. I'll set it so that each time I turn on this M11 bit, my stepper motor, the servo motor, will rotate 800 pulses, corresponding to 1 revolution. Here is the velocity. I'll set it to 1000. 1000 pulses per revolution. Okay, so we have finished setting up the stepper motor. Now we will download the program to the PLC. You will select the PLC and then click the download button. Next, in the PG/PC interface section, you will select the Intel Internet connection. Then you press the load button, select the PLC, and then press the load button. In the Stop Module section, I will select Stop and continue to press the load button. Okay, I will press the Finish button to complete. So, we have successfully downloaded the program to the PLC. Now I will switch to monitor mode by pressing the Monitoring On/Off button. And you can see these are the blocks that I've added. And now, to run the stepper motor, the first step is to turn on to supply power to the stepper motor. I'll turn this M10 bit on. Right-click and select Modify, and then modify to 1. At that point, power will be supplied to the stepper motor. The next step to control the stepper motor is to go to the Move Relative instruction block, then select the M11 bit. Right-click the M11 bit, select Modify, and select Modify to 1. Then you will see the stepper motor rotate 1 revolution. And I will explain what is called move relative. As you can imagine, move relative means the reference coordinate will be the current coordinate, meaning I am currently at 800 pulses. Now, if you turn on this M11 bit, the stepper motor will run for another 800 pulses. And you will turn it off. And if you turn this bit on again, it will run for another 800 pulses. So, the current coordinate is the reference point, and it will run 800 pulses relative to the current coordinate. It's different from move absolute, so now you understand what move relative is. In the next lesson, we will learn about move absolute. Okay, that's all for today's lesson. So, I hope you've understood this lesson. If you find the video helpful, please subscribe and share the video for me. Thank you for watching.